Hello, I'm Dr. William Schlosser, Washington State University, School of the Environment. This is my classroom.
Okay, well, I'm going to get back to the topic of the day, and I hope everybody has watched today's lecture video. We're talking about movement here, dispersal. This is the logical flow that took us from metapopulations over to speciation, whether it's sexual or asexual reproduction. And then tracking it out, the end of that second video, the asexual reproduction, I talked a lot about this species interactions. How these species get together and interact is got some positive and some negatives. That positive side is one that we're really going to key on throughout everything we do. Now, interestingly, earlier this morning, I had a meeting with a student in the class, and he's with us right now. But we're talking about the mycorrhizal associations. That was the pre-class video from last Friday. Okay. And when that professor was talking about what she did with mycorrhizal association to understand how the trees talk to each other. Okay, it's a very nice and well-presented TED Talks video she participated in. She has written hundreds of articles on this. She's done dozens of different YouTube videos. These all flow into really what the take-home message of what we all have. We got to see how these trees can really talk to each other. And really, it's through that internet. That internet, that very first connection between the different species was the mycorrhiza. We're talking about a mushroom here. In a symbiotic relationship that says, I'm going to allow you to talk to this tree or that species or this bush, and that exchange of information. In this case, it's the nutrients that the trees need, the plants need. Every one of them do, but what's the mycorrhiza bring to the game? It brings a great hypha mass that is pushed below ground. It doesn't have anything green on it. There are no chloroplasts. It cannot photosynthesize. Ain't going to happen. What it can do, though, is get deep in the ground. It can absorb the water that came from the atmosphere at a very deep level. It has taken all the nutrients with it as it flows through. You know, I've talked about that a lot on Kamiak Butte. As the water hits that substrate material, that quartzite, and it flows through fast, it dissolved nutrients as it did. And down deep in that layer, whether it's the quartzite or up here in the flood basalts or any other soil types you see, there's nutrients that were dissolved. The mycorrhizal mass can capture that. It can bring it out. Now, with that water in its hypha zone, it's pulling it up to the plants. Why to the plants? Because the plants have something to trade. They have extra carbon that they've captured. They did the photosynthesis above the ground, right? They did everything we talk about there. Chloroplast brought it in, and now there's carbon in there. They pass that to the mycorrhiza. Mycorrhiza are trading it off for the water, that's super big, and the nutrients that were enclosed in it. Now the plants benefited, the mycorrhiza benefits, and they can both grow. That connection between the two, you saw the pictures of me in Nanaimo, Vancouver, British Columbia, standing next to these tree stumps that had been sawn off. The trees were cut. There was a hazard in the park, and they cut them down. Well, that was about 5 years before I got there, and here all the tops are healed over bark. Well, you got to be kidding me, right? There is no way that tree could have photosynthesized because every bit of its greenness was cut away. It's gone. It's in the mill right now. Okay, it's already in somebody's house because it had been about 5 years. But you get the idea. That only could have happened because of the mycorrhizal associations. That is symbiosis. Yeah, that was part of the video from last Friday, and again mentioned on the mix for today, because that symbiosis, that relationship that these different species have. There's about 7 of them that you're going to see in the video. You're going to understand what they mean and start to apply them to the things you see. I want you to really put everything into this mix to say, early on in the semester, I told you that ecology is about the study of relationships. These relationships plants have with each other and with themselves, that is the process of getting through time and space. This is a great understanding for you to really kind of bring into your mix to say, now I'm taking that speciation, that asexual reproduction, all these different plant interactions that we see, and applying it to a very specific idea. When I say distribution, I really mean movement. the movement of all the genomes, all the plants and animals. It's not just about the elk and the deer walking across the road. It isn't just that, but you see it as the species interact within their habitats. Now, you saw one of the videos or the sections of the video from today, that herd of elk in Montana moving across from its wintering ground to its where they're going to calf, where they're going to spend their summers, because they're not going to do a big movement when they have the babies on the ground. They got to let them grow, let them and mature. Okay, that is a normal part of that species. Now, I also talk about emigration, immigration, migration. Okay, all these different spells and ideas of what the different species are interacting for, you got to put them into context, but also say, I'm not going to confuse the idea of the annual movement of an elk herd that stays as a herd to cut through the different areas, okay, for its wintering grounds, summer ground, spring calving grounds. That is a normal part of that species' adaptations to their restrictive environments. I keep talking about those words, folks, because that is how you can define how these species adaptations come to light. That adaptation is something that I really want you to key on and understand as I apply it to the biotic land, the biotic life of all living individuals. That's kind of the energy that they get and how they adapt, how they thrive and survive. Okay? Again, I'm pushing these all through. Watch that lecture video. If you haven't already, do it. If you did, you may want to watch it again, because there is one other highlight that I'd love to bring out. And that is my friend, the lamprey. Okay, that lamprey, you saw in today's lecture video how the inland tribes are really tapping into it. Several years ago, I was working in the contract world, and I was a contractor for the federal government, for the tribes, states, different governments. An associate I found with the U.S. Fish and Wildlife Service, Chris Peary, Dr. Chris Peary, wonderful guy. But I met him not just formally, but also informally, because my granddaughter was a friend with his daughters. He had twin daughters. He said, Bill, we need a study of lamprey habitat in the inland waters. I said, great, let's hit it on. We designed it. And finally, the funding came along. He says, now we got to trim it back to one drainage. He was disappointed. We wanted to do all of eastern Washington, North Idaho, all of Idaho, because that Snake River flows all the way down to Boise and further out, all the way to Yellowstone National Park. That was a long reach. We were ready to do it. Anyway, the one drainage we chose was a Soden Creek. A Soden Creek is just to the south of here in Pullman as you get down to Lewiston, Clarkston. Okay, Clarkston is in Asotin County, and Asotin County is where this Asotin Creek resides. That was our study area about the habitat for Pacific lamprey. But that little fish is a parasite. When it matures, it latches onto the side of a fish, a salmon usually. It sucks their juice out. It doesn't kill that salmon. And a lot of times that lamprey will even attach to the fish as it's going to spawn. And by doing that, that lamprey gets a free ride up the river on the side of that salmon. Yeah, it'll finally detach. The salmon, it can spawn. It's really hurt. You see one of the photographs. Oh my golly, it looks pretty brutal, pretty obscene. That salmon still lived and made it to spawn. It just had this big old score on the side. Okay, that's a Pacific lamprey again. Now we're talking about a different fish species, its modalities, its movement through the ecosystem, how it adapts. It's tried to adapt to the rivers and with the dams. Okay, that's another adaptation that is double tough to do. Follow through on this whole idea of what the Yakima tribe and the Nez Perce tribes are doing to try to reestablish the Pacific lamprey, who've been severely hit by our hydroelectric dams. Okay, salmon can make it through because of our fish ladders, yeah, but we don't have fish ladders everywhere. You just go just 45 miles from right here in Pullman, and you're looking at Dorsack Reservoir in Orofino, Idaho. That dam has no fish ladder. That was a great place where sockeye salmon used to spawn. Okay, we had all 7 salmon species breeding in that river system, but now pretty much all of them are gone. We have that hatchery at the base of the dam, but they don't restock the lake, of course. Now, what do we call it when the sockeye get landlocked above the dam? We call them kokanee. Okay, and there's a lot of kokanee fish, and has been for years. Well, okay, decades, because it was 1972 when that dam was put in, and it's been wonderful fishing ever since then, but not for the salmon that we originally had. And now these salmon, instead of being 24 inches and more long, now they're down around 6 or 8 inches. They're small little rascals, but you get 25 a day. What are you complaining about, right? Well, complaining about a change in the balance of equilibrium. Complaining about a change in the balance of equilibrium. That's really the theme that I keep spinning around on this whole discussion, is to say, I'm talking about biodiversity again. How do we achieve that biodiversity mix? Really, I'll loop it around. The big picture here is to say that biodiversity is engaged when we understand that the environment is constantly changing. The abiotic realm, it's always in a state of change. That was the very first lecture video you had in class, right? Where you looked at the changing in temperatures, that warming and cooling, the ice ages and the saunas. That is the natural environment changing long before us humans got here to muck it up. That is a natural process. The adaptations of the species are what gives it life. Biodiversity happens because the species are able to adapt to the changing environment. Now, as we mess things up with our anthropogenic changes, yeah, we got that. We're speeding up a lot of things, maybe taking it in a place where it hasn't been before. Are the species able to adapt? Yeah, they are. Is it at the same speed as we're messing things up? Probably not. So that is where we lose the effect of biodiversity. Where we have it, where we see it, and we can maintain it, yeah, we have a great success. This is the process that I want you to really think about, how we as humans have changed the equilibrium in the environment. Oh, great story, I love to say, and I know that Kyle Scott, he's in the class, I think it's in 302. They asked me to speak about a story from something that happened in the past, something in natural resource management, just a short story. It really makes effect to share it with you right now. Quick story about, and we've talked a lot about the elk. Speciation video, we talked about how we used to have Cervus canadensis, variety canadensis. That was the elk species all across the northern hemisphere. That was in Asia. That was in North America. That Cervus canadensis today has that blockage. We talked about that allopatric speciation that separated Asia from North America. Now, the elk on both sides of that line, they had different restrictive environments. They adapted to it. Now, so we still have elk in Asia, North Asia, where I was working in the Russian Federation in Khabarovsky Krai. That whole area, it had elk, it had moose, it had deer. That I did get to go elk hunting with my forest management peers. They invited me out. Hey, Dr. Bell, you got to get out here with us. Take a week off. Let's go hunting. So it took me into the remote Taigov where we had they had a hunting camp. Got it all set up. Now I took with me, knowing that in North America, in the United States, we've eradicated the wolf. Now I didn't talk to them at all about this. It's a reality that I know. We have a lot of elk, a lot of big herds. I've never thought about why those big herds are so different than what we would see in the Russian Federation. It was in Northern Asia, right? Well, we get over there into this hunting camp and we hear some bugling at night. Very, very little. If any of you have ever spent time in the woods in the fall, you know that the bugling can just go on and on. It's just brutal. It's going to keep you awake all night. I celebrate it. It's kind of like hearing the rain at night. It's wonderful. I'll take it. Going back to this Russian example now, I had taken a small reed, okay, that reed that you put in your mouth and it'll allow you to simulate the ring of an elk call, the bugle. Okay, I did it. I had it with me. I didn't kind of show it off anything in front of my hunting peers, but I got a little piece of bark, a strip of birch bark, rolled it into a cone, and now I had a bugle tube. Okay, and we're out there hunting. We're all set up. We're supposed to watch this, or we decided we're going to watch this canyon, this drainage area, that there was evidence that that's where the elk would move. Got all set up. Man, I'm going good. The sun's come up. I'm thinking this is the perfect time, and I send out a bugle. And one of the guys, it was a good bugle, by the way. I thought, man, I'd shoot myself. It was so good, right? Okay, One of my associates came over to me and he says, "Что тебе делаешь? What are you doing?" I said, "That's an elk bugle. You see this little reed?" And I showed him everything. He says, "Why do you do that?" that isn't going to attract the elk. This isn't something that you're going to have any success with. We were quiet the rest of the day. We didn't see anything. Well, later that night in the hunting camp, we started talking about it some more. And one of the guys, he says, I understand this. In America, you killed all your wolves. We didn't do that here in Russia. I know we're backwards and all that, but we don't kill our predators. We let them go. That's part of the natural environment. When you took out those wolves, the behavior of the elk has changed. It's changed to the point that here we'll hear a bugle maybe 2 or 3 a day. That's it. That isn't something where they stand in place and attract everything to one little location, because the wolves would hear that too. The wolves would come in and have a heyday. That is the fall down of a big herd of elk. Okay, over in America, we know that there's huge videos, and I've used them in class. You've seen them in the lecture videos, especially on speciation. There's a big herd of elk out there. They're bugling. They got cows all around, maybe another bull herd over there. You've got 300 elk standing in one spot. He says, that's a call out for the wolves. They'll come in and they'll have a heyday. They'll wipe it out. The behavior of the elk in the United States has changed because of this restrictive environment. There's no more wolves. They can get together. They can have a party in heyday. Forget about this whole balance of nature thing. We just unbalanced everything. When we did that, we changed not only how the elk behave, but how us hunters do too. Because when I got to the Russian Federation and did that, wow, I had to really track myself around to say that was assuming that everything is in equilibrium everywhere, just because it's biodiversity. That's not. Do they have any of those herds of 500 elk in one spot? Nope. Do they have wolves? Do they have the elk and the deer and everything else? Yeah, they have them. And they have one other thing, salmon. Okay, that imbalance of how the elk being removed from the ecosystem changed how the herbivores behaved in the river riparian zones. They're feeding on those hardwood trees. They're brush. Everything's fed back. It's huge. It's a big effect that was brought on because the wolves were taken out. That equilibrium balance totally modified. And one of the losers are the salmon. Yeah, I'm talking about salmon right here in Pullman, Washington, right? Because we have them coming up the rivers from the ocean. They're going into South Idaho. They spawn. That is a normal part of their life history. But with the dams, with the removal of the wolves, yeah, we've really changed a lot. Did it touch biodiversity? Sure did, in a big way. This is the way things are all connected, folks. Now, and I talk about in this lecture video for today, whether it's the Pacific lamprey or the other species that interact, those mutualistic, symbiotic, these parasitism kind of relationships that the species have. This is how you're going to really apply them. Understand that this interaction, it has ripple effects that go a lot further than any of us can realize. It is the idea that if somebody has said, I'll even back this up 30 years ago, if somebody has said that the wolf removal is going to ultimately reduce our salmon runs, I said, no way, it couldn't be that far, or prove it to me, right? It does, and it is. This is something that I got to ask you now with the salmon runs reducing. We've all seen that and talked a lot about it. I got to ask you, what's next? If the salmon runs are down, and we talk about the lamprey, they were hit as well, who else or what else is going to change? We can prognosticate about that for hours and days and have a good time doing it. Throughout this entire mix that we're running on now, folks, I want you to really focus on how that movement is an effect of adaptations and change. All right, we talk about speciation. We did that. The asexual reproduction as well. All these different relationships. Now, looking at this idea of movement, it's not just species moving into environments where they'll have better success. It's not like that. It's the idea that the species are going to adapt in their genetic mutations, that random thing that we talked about. It's going to come out to the adaptations that fit a new niche within the environments that they live in. That filling of the niche and substantiating it. That just because you fill that niche today doesn't mean you will in a month, okay, in a year, in 10 years or 20 or 100. That niche environment area, it may shift as well. We know it will. How adaptive are the species to fill that niche and become sustainable, maintain our biodiversity?